Math 3, Unit 2, Section 1. So today we're going to be talking more about piecewise defined functions. So we started looking at this in Unit 1. Remember, we have different graphs on one graph, okay, or different functions on one graph. Okay, a function is increasing on an interval when the y value increases from left to right. So going from left to right, if you notice here on this graph, see how it's starting here? Do you guys see how it's going up? That would be increasing. Okay, a function is decreasing on an interval when the y value decreases from left to right. Okay, so if you look right here, do you see how this is now going down? Decreasing. Okay. A function is constant on an interval when the y value remains the same. A relative minimum is a point where the function changes from, so like right here, this, okay, actually this is a relative max. So if you're going here, do you see how it's going to be changing from increasing and then it goes to decreasing? Okay, so this is decreasing. Hold on, did I just? Minimum. So you have a minimum, it's going, oh, right here, decreasing to increasing, yes. And a maximum is a point where it changes from increasing to decreasing. So it's important to know that in order for something to be a maximum or minimum, it has to change directions from increasing to decreasing, okay? Or from decreasing to increasing. If it changes, like if it were to go like constant right here, that would not be a relative max or min. It has to change from increasing to decreasing or vice versa. Okay. So answer the following questions about this piecewise defined function f of x below. State the open intervals. So first of all, it's saying open intervals. Therefore, you're not going to use any brackets, okay? So remember that open means we will use parentheses. Okay, on which f is increasing. So as we go through here, do you see how this is going up? It's increasing. So how would I label it? How would I write that open interval? So if you have an arrow here, that is what? Negative infinity. So it's increasing from negative infinity, and where does it stop increasing? What value? And maybe you can't see this, but so I'm going to make this a little darker. This is our y-axis. So we're looking at our domain values when we're talking about this. So it stops increasing here at what value? -1. We're looking at just the x values. Okay, so from negative infinity to -1, because we're looking at our domain. And is there any other places on this function where it's increasing? And where does it start increasing? 1. And then there's a point here, so that means it stops. And what value is that? 7. Okay, so the next one asks, where is it decreasing? So do we see where it's decreasing, where it's going down? Good. Yeah, so right here at -1 to 1. And all of the values that I'm putting are from our domain, from our x values. So whenever you're talking about the intervals, unless it says range, you're always taking the domain values, okay? So if they want the range value, if they want the y's, they'll say it. Otherwise, it's just when you're giving these intervals, it's from your x values, okay? All right, state the domain and range of this function. So the domain, again, this is going from left to right. It starts at what? Negative infinity, and it goes all the way to 7, and we'll use a bracket because this is talking about domain and range. It didn't say open intervals. Okay, for the range, this is where we're doing our y's, so we're going up and down this time. What is the smallest range value? Good, negative infinity. Okay, as this goes up, it keeps going up, and then it looks like it stops right here. There's nothing above this point, and so what is that value? 4. And bracket or parenthesis? Bracket. Okay, so this is something new. This says state the coordinate of any relative minimums. So we have basically, if you look on here, this is infinity, so there's like no point, correct? Then you have this point right here where it changes directions. You have this point right here where it also changes directions. And you have this point right here, but I just want us to talk about that. Is that one right there changing directions? No, it's just, it stops, right? So that means this is not a relative min or max because it doesn't change directions. It has to like go one way and then turn around. Okay, so coordinates of any relative minimums. What would be a relative minimum on this function? Good, this right here is a minimum. Okay, it's changing from decreasing to increasing. This is a minimum point, and so that coordinate is at 1, 2. Okay, what would be the coordinate? Is there a maximum on here? Yes, so this is a maximum, a relative maximum, and what's that coordinate? Good, negative 1, 4 is correct. Okay. Does anybody have questions about those? Oh, okay, good. Yeah, good question. So, yeah, when you're just giving a coordinate, when you're using brackets and parentheses, it's like an interval. You're talking about points like going from one direction to another on the graph. When you're talking about a coordinate, you're talking about a specific point, and you always just use your parentheses, never brackets. Okay? So we're just talking about one point. We're not talking about a whole bunch of points within an area. So like this right here were all the points from here to here. This is all the points from here to here. This is, and so that's when we're using our brackets and parentheses. This right here is talking about all the points that are increasing and so on. These right here, when you just use these type of parentheses, this is just saying this is a specific point on the graph, just this point. Okay? All right, anything else that you guys have questions about right now? Okay, so this says write a two-pieced, piecewise defined function that accurately represents the graph of f shown above. So we have to write this piecewise defined function, okay? There are two different graphs on here. Do you guys see the two different graphs? Or two different functions, I should say. Okay, so I'm going to put a highlighted line here, separating the two so I can see, kind of look at them separately. Okay, and so we're going to go ahead and say, you know, this is my first one over here, and this is my second one over here. So starting, and they told me there were two of them, so that would make sense. I have two different graphs here. Okay, so starting with our first one, what type of function is that? Quadratic. Good, quadratic is correct. Okay, our quadratic function, okay, is written like this. I'm just going to kind of use our formula for quadratic functions. Y equals a parenthesis x, and then we have like plus or minus something squared, and then we have plus or minus something, correct? Okay, how do we figure out what goes into these spots? Very good. Do I have a vertex on this graph? Yes. What is the vertex? Okay, so my vertex is -1, 4. Is everybody okay with that? Okay, so I'm going to move this up so you can see what I'm writing. What do I do with these values? How do I write them in here? Okay, so plus 4 at the end. Okay, this is the x value, the y value. This number always gets put with the x in the parentheses. So good. Inside here, it's going to be plus 1. Okay, so now I just need to find the a value. This is where some of you messed up on your test. When you're finding the a value, you cannot use the vertex. You can't plug that same value back in. You can choose any other point on here. I'm going to go ahead and choose this point because it's an exact point. I know it's marked. And so what is that point? 1, 2. Okay, again, I'm going to label these with x and y to make sure I put them into the correct places, and then we have to solve for our a value. Okay, so we're writing instead of y, I'm going to write what value? 2. 2 equals a, parenthesis, and then what am I going to write? 1, good, plus 1 squared, and then plus 4 at the end. Okay, then we're going to simplify. 1 plus 1 makes what? 2. Get the order of operations. And then 2 squared is what? 4. So when I write this, it's 2 equals 4a plus 4. And then we're going to solve for a, so I'll subtract 4 to both sides. -2 equals 4a. And then my last step would be to divide by 4. And what does a equal? -1/2. Does this make sense that this is a negative value for a? Yes. So always double check that it makes sense. And it does. So my equation for this quadratic is y equals -1/2 x plus 1 squared plus 4. Is everybody good with that? Okay. So next we're going to write the equation for the second part of this graph. And so I'm going to write 2 here. And if we look here up at our second graph, what type of function is that? Good, linear is correct. So when we are writing the equation for a linear function, it is y equals, we could do an m or an a. I'm going to do m. And then we have x plus or minus something, and then plus something at the end. Okay. With a linear function, it doesn't have a vertex. We just have to choose one point as a starting point. You could choose any point on here. It doesn't really matter. Okay? So for this one, let's just go ahead and choose this point that's right here. Okay? So that point is at 1, 2. And so when we put this point into this function, what do we write with the x? -1, and then plus 2 at the end. Is everybody okay with that? Now, we can use another point to find our slope, or with a line, could I count the slope? Yeah. Okay, so I'm going to just count from this point to this point in order to find my slope. So if I count up, it goes up 1, 2. So remember, your slope is always rise over run, okay? Or your, change in y over change in x, okay? And so this is going up 2. and then it's going over to the right, 1, 2, 3, 4, 5, 6. 2 over 6. And then you always want to reduce that. So in this case, what would that reduce to be? 1/3. So my equation is y equals 1/3 x minus 1 plus 2. Okay, before I go on, do we have any questions on that? Okay. When we are, come to this side. This, if you wrote it this way, it is okay. Sometimes though, when you look at, when you have a line, it's not written with the parentheses. They distribute it and write it without the parentheses. So let's just go through how to do that. Is that okay? And so we would take the 1/3 and we'd multiply it through. So 1/3 times x is 1/3 x. 1/3 times negative 1 is negative 1/3, correct? Okay, plus I have 2 here. Now, because I have this 1/3, if I want to end up adding 2, what would I need to end up getting? You would want to change this into a fraction and get a common denominator. So we would write 2 over 1, correct? But in order to change that to have a denominator of 3, which I want it to have a denominator of 3, 1 times 3 is 3, and 2 times 3 makes 6. Is 6 over 3, if you reduce it, does it make 2? Yes. So all I'm doing is just rewriting this so that it will help me with this function. You're confused. All I'm doing is getting a common denominator, right? So the common denominator, this is a 2. The denominator would be 3. Why 3? Because this one's 3. And I want to end up adding these two numbers together. Okay? So this has a 1/3. So I want this one to have a 3. So if 2 right now has a denominator of 1, in order to make it a 3, I'd have to multiply it by 3. And then whatever we do to the bottom, we also have to do to the top. And you can double check that if you were to reduce this, it would make a 2. So we've just rewritten it in a different form. Okay? So when I write this equation now, y equals 1/3 x. What is negative 1/3 and 6/3 together? 5/3. Okay? A negative and a positive will subtract. Take the sign of the bigger number. 6 minus 1 is 5. You keep the denominator. Okay. All right. That's kind of tricky. So we have all this. Now we're going to write our piecewise function. Okay? So I'm going to kind of box this out here. So when you are writing your piecewise functions, they already told us that this function is f of x. Okay? Equals. And we are going to do a brace. Like that. Now, the first equation from our function going left to right is our quadratic function. Okay? When you are writing it over here, do we write the y equals part? No. Do you guys remember that? And so because f of x and y are the same thing, and so I'm going to write negative 1/2 x plus 1 squared plus 4. And then this is where we go if, and we have to state the interval, but when you're stating the interval, you write it in inequality form for our piecewise defined functions. So what would be the interval for this part? Good. And I'm running out of room here, so I'm going to write it down just a little bit. It's normally on one straight line. Negative infinity is less than x is less than or equal to, and where did this function stop? 1. Okay, ask me some questions. So we wrote the function here, okay? And then we just wrote the domain that that function is on. Okay? So now we have to write the second function. So we're going to write 1/3 x plus 5/3 if, and then we have to write this domain of this one. Now one thing is, do you see how I already put the equal to 1? Only one of them can have the equal to. So when I'm writing this one, I'm going to put 1 is less than x. So you could have put the equal to with the top one or the bottom one. It would be okay either way, but it can only be on one of them. It can't equal 1 on both of the functions. Okay? Is less than or equal to, and where does it stop? 7. If on here this had been an open circle, then we would have just had the less than sign. Since this has a close, we do the equal to. Okay, and what I was saying is only one of the functions can be equal to here. So only one of them gets the 1. Okay, and that's it. This is your answer. That's your piecewise defined function. Okay, do you want to ask me any questions before we move on? Yes. This? No. So if you were, I just want you guys to understand how to change it. If we want to leave it in this form, I am totally fine with that. Just know that sometimes maybe your answer won't exactly match someone else's, but if you had distributed it and simplified it, it would. Does that make sense? Okay, yes. So that's what I was saying. Do you see how this one has the less than or equal to? Then this one can't. So only one of these functions can equal 1. So one of them has a close and then one of them has an open. But you could put it on either one. It doesn't matter. Okay? All right, other questions? Okay, we're going to get a chance to practice this again. So we're going to do this next one. And again, it's kind of hard to see the x and y axis, so I'm going to draw it a little darker. You might want to do it on yours too. Okay, so answer the following questions about this piecewise defined function shown below. A says state the open intervals on which f is increasing. So I'm going to give you about 30 seconds. Try to write the intervals on where it's increasing. Okay, who thinks they can know where the function is increasing? How many different locations is it increasing? Just one place, okay? And it is increasing from, and remember, we're always going to be using our x values unless it says range. So whenever I'm describing something, I'm using my domain to describe it. So it is increasing from 0 to 2. Do we all see that? Okay, 0 to 2. Okay, now state the open intervals on which f is decreasing. So I'm going to give you another little bit of time to try to write where it's decreasing. How many different places is it decreasing? 2. And so this first right here, because you always read graphs left to right, just like reading a book. Okay, and so this one starts where? -4, and it decreases till it gets to 0, and then it's decreasing again where it starts at 2 and it goes till 4. Is everybody okay with that? All right, where is the function constant? So constant is where you just have that straight line. It's not increasing, it's not decreasing. And so that interval where it's constant is from where? 4 to 6. Okay. State the domain and range of this function. So my domain, it starts at what value? Bracket or parenthesis. Good. -4, and goes all the way to what? 6, bracket or parenthesis. Good. Okay, your range, this time they asked us for the range, so that's when we're going to give the y values. The smallest y value is down here, which is what value? -6. And going up, the largest y value is at 1. Okay? State the coordinates of any relative minimums. So I'm going to highlight all these points here. Okay. Not all of them are mins and maxes because remember it has to change direction. So do we have any minimums? Okay, what would be a minimum? Good. 0, -5 is a minimum. And I'm going to go ahead and mark it on here so it's easy if I'm looking back at my notes. That is a minimum value. Are there any other minimum values? So the answer is no. And I can tell that some of you are thinking about this one. Why is this one not a minimum? Thank you. Good job. Why is this one not a minimum value? It's decreasing and then it becomes constant. So that is not a relative min or max. It has to change from increasing to decreasing or vice versa. Okay, are there any maximums? Yes. And what's that? 2 -2 is correct. So that's a maximum. Are there any other maximums on here? Or relative maximums? No. Okay, because nothing else changes directions. All right, now this next part, it says write a 3-pieced. So this time they want 3 equations. Yes? So this one is not a relative maximum because it's not changing directions. So remember, it always has to change from decreasing to increasing or change from increasing to decreasing. And this is not changing directions. It's just starting. Okay? All right, so this time we're going to write a 3-pieced, piecewise defined function that accurately represents the graph above. So where do you think we would mark these? There's actually a couple different ways you could mark them. For today, this is how we are going to mark them. Okay? We are going to put we'll make 1 to the left here. Okay, what type of function is over here? Linear absolute value. And then we're going to mark this one, and we're going to make this one is just going to be linear. And then this right here is also linear. Good. Okay, so we are going to number these as 1, 2, 3. You can't see how I numbered them, but I did. I think it's helpful when you number them because you always start left to right. It will help you kind of keep everything organized. Okay, so our first function, number 1, you guys already told me is linear absolute value. Okay. When you are writing the function for linear absolute value, I'm moving this up a little bit. It is written as y equals, you could do a or m for linear absolute value because it is a line. I'm going to put a for right now. And then absolute value x, and it'll be plus or minus something inside the absolute value bars. And then plus or minus something at the end. Where do we get those values? from our vertex. What is my vertex? 0, -5. Okay, label those as x and y. So inside the absolute value, what would I write? Yeah, we can just put plus 0. And then at the end here, I'm going to have what? Plus 5. So the only stuff that's opposite is what's in your parentheses or inside the absolute values. And then can I use slope on this one? Yes. Okay. And so my slope, if we look, and I'm just going to choose like this point, this is going up 1, 2, 3. You're right. This is a -5. Good job, Candy. Okay. That's a -5, right? Okay. All right. So now back to the slope. Up 1, 2, 3 over 2. Now, with linear absolute value, you need to decide, is this going to be a positive slope or a negative slope? So if you look at the V, is the V going up? Yes, which means it's positive. If the V was going down, then your slope would need to be negative. Lawrence, did you have a question?
Oh, no,
You're okay?
yeah, for some reason I thought I said 4 P's.
Oh, okay.
Yeah.
All right. So we're going to go ahead and write this function here. And so that will end up looking like this. Y equals 3 over 2, absolute value. Now, do I need to write x plus 0? No. So we can just put x and then -5. Is everybody good with that? Any questions? Okay, let's move on to our second graph or function. Okay, so the second one, if we look at it here, is what? Linear. And we know that for linear functions, it is y equals m parenthesis x plus or minus something, and then plus or minus something at the end. In order to get those values on this, we just need a starting point. So what is my starting point for this one? Good. We can use 2, -2. We could have used this point as well. Either way, when you simplify it, it'll get you to the same equation. So we have 2, -2. Label it with x and y. So when I write it up here, what am I going to put here with the x? -2, and at the end it'll be -2. So it's only what's in parentheses that we do the opposite for the x, and then whatever the y is, that goes on the outside. Okay? What is my slope? Could we? So yeah, so if we count from this point to this point, it's going down 1, 2, 3, 4. So -4, and then down or right 1, 2. So -4 over 2, which reduces to be -2. So if we take that and write it into our equation, we have y equals -2, x minus 2, -2. Now, the nice thing about this function is that there's no fractions. This one is very easy to simplify, I think. So let's go ahead and simplify it. Do you know what I mean by that? Distribute the -2 and combine like terms. So -2 times x is, and -2 times -2 makes a +4, and then we saw that -2, and so we end up with y equals -2x, and then 4 minus 2 is +2. Okay, so we have our second linear function. Are we good? Okay, our third one. And because I want to leave space over here, I'm going to do my third one down here. And so my third function is also linear. And if we go back and look at our graph, it's a straight line like this. How do I write a straight line like that? It's just going to be y equals a value. And what is the y value right there? Very good. Y equals -6, and that one's done. Okay? So now we are going to write the piecewise defined function. Are you ready? Okay, we're going to go anyways. Okay, so we're going to do f of x, because they told us it's f of x, equals, we're going to make our brace. Okay, so our first function, we're going to write that down. Okay, so we have 3 over 2, absolute value of x, minus 5. And then using inequality notation, it starts where? And remember, we're just using our domain values. It's starting at -4. And we're going to do less than or equal to, because there's no open circle there at the -4, x. And then we'll go ahead and use is less than or equal to, and where does it stop at? 2. We're just using our x values. So this function right here started at -4 and ended at 2. So all the values, that when you're writing them down, you're writing them from the x-axis. You're writing your domain. Okay, are we good there? All right, so then we have our next function, number 2. And so we're going to write -2x plus 2. Oh, and I forgot the if here. Sorry. If, and this function is going from where to where? 2. I'm only going to use less than this time because I already have an equal to on that 2. Only one of the 2's can have an equal to. So x, and then I'm going to put less than or equal to, and where does that function stop on the domain? It started at 2, it stops at 4. Okay, and then the last one, I just write it as what? And we don't put y equals because this is basically representing our y equals, and so we just write -6 if, and this one starts at what? 4. I'm not using the equal to because I already used an equal to on that one. So is less than x, is less than or equal to, and where does it stop at? 6. And that's it. We've written our function. Okay, any questions?